Hello and welcome back to the Coking.com channel here. I'm with our friends at Berthold, and if there's any doubt that we are here in Germany, check out that in the background. We're in Germany and we're with Henke Mann, and she's going to tell us about online density measurements of the process and how valuable they can be. So Henke, could you introduce yourself a little bit to our audience?
Sure, Evan. Thank you for being with us. My name is Henke Mann. I'm working for Berthold 28 years now, and I'm leading the product management and technical sales department.
Oh, perfect. Well, thank you for joining us. You have set up a lovely demonstration for us here on the shop floor. What do we have in front of us?
Here you see a typical clamping device with mounted radiometric density gauge on your side. You'll see the point detector with a mounted collimator.
So this is a point detector. If anyone wants to know about what's happening inside of this tube, I'd encourage you to go visit our other video where they describe the internal components of this piece of equipment. So this is the point detector.
Yes. And here on this side, you find a radiometric point source shield. Mm-hmm. So the source is inside the shield, and only the obvious yellow thing is the shield itself.
Yep, same story. Another video discussing what's inside of that point source. But together with this assembly clamped onto a pipe, what does this give us the ability to do?
With this setup, you can measure very, very precisely density of any liquid in a pipeline. Whether it is slurry or oil or water or whatever there's in, you can measure very, very precisely the density.
So when you say precisely, how precisely do you mean?
Up to 0.001 grams per cubic centimeter.
So 3 decimal places on specific gravity?
Yes.
I'd say that's pretty accurate.
It is.
Yeah, perfect. And you mentioned slurry applications. This is something I think that you've done for many, many years.
Yes.
You do this instrumentation common in slurry. So how is that used?
It is used, for example, in slurry lines in the mining industry. We use it in the chemical industry, petrochemical industry, to measure very precisely density of chemical fluids, liquids, also concentration of chemical liquids could also be measured. That's also what we provide. And if you add a velocity signal, we can even provide you with a mass flow signal.
So I think that's why I wanted to bring this to the attention. When they were telling me about this technology, I am impressed because density, as you said, is an indication of chemical composition. And as you know, on this channel, all we really care about is light coking.
Yeah.
We're singular focused here, but we really are interested in the fact that our feed coming to the unit is highly variable, right? I mean, I work with clients all over the world, and they tell us that our feed quality is changing for sure daily, sometimes hourly, right? And we take feed samples maybe on a daily, if you're lucky, more likely a weekly basis, but it's changing all the time, and density can be a good surrogate for the feed composition. So by having this technology, it can enable you to know what's happening from a density standpoint.
Correct.
Yeah. And furthermore, if you combine that with mass flow, one of the things that we're always trying to get our customers to understand is their material balance, so that gives them the ability to optimize their yields and change their process for the better. And knowing mass flow in, mass flow out, gives you the ability to close that material balance in a very accurate way.
Correct.
And so when we think about this from a density and a mass flow standpoint, you also mentioned that it can also be used to detect the presence of water.
Correct.
So how would we do that?
In that case, basically to measure the presence of water is also a density measurement, meaning you check the density of the liquid. If the density is getting higher, if it's a mix of oil and water, if the density is getting higher, then you know it's more likely water. So even if it's above one specific gravity, then you know exactly it is water. Mm. If it's below, then you know it's oil, or it's at least an oily water.
For sure. So the application, when Henke was describing this to me, that clicked in my mind was slop production. So around the refinery, as we know, slops are generated from a variety of reasons. They go to a slop tank. and they have to be reprocessed. Now, this can happen either in the crude unit or this could happen in the delayed coker. So I feel like the ability to sense the presence and the quality of your slops coming back into your unit is very critical. So I know I've run into this situation before where we've had a slop line coming into the unit, and there was a control valve that would trigger shut if and when the presence of water was detected, because if that water arrives in the fractionator, it can vaporize, cause all kinds of damage, right? So
you want to avoid that, don't you?
We definitely do not want that to happen.
Yeah.
So the slop application for this density also seems to make sense as a potential application.
Absolutely, yeah.
And it's something
easy to mount.
Well, that's what I wanted to push on in at the end here. Is it's non-intrusive, right?
Not at all. You just clamp it on from the outside. It's easily retrofittable. At later stage in the process, we even can do a 1-point calibration, which is not something not everybody can do. So if we have one known density, we can start with it and at a later stage a second point. But the first measurements can be done with a 1-point calibration.
And it can be done calibrated on water or calibrated on oil.
Correct.
Or some combination thereof. You just have to know.
Yes, you just need a known density.
Yeah. So this example right here is a clamp-on situation. You can see it's on a pipe spool. So this is sort of a unique layout just for our demonstration purposes. But what are the ranges of pipes that you can accommodate with this type of measurement?
We can go from 20 millimeters, for example, up to 2-meter pipe.
Yeah. So
there's basically everything possible. We even do density measurements on the coker itself, you know that.
Yeah, on the vapor lines themselves, using this same technology, it can be used in a variety of different places. So
absolutely, yeah.
This is why I wanted to take the opportunity to share this with our audience, get a little demonstration of what the ins and outs of it. So thank you very much, Henke. This has been great. I think this is a technology that I'd personally like to see more of in delayed cokers around the world. Feed density, slop density, it's a winner. So thank you very much, and I thank my friend at Berthold for hosting us. And enjoy more videos at the coking.com channel, and we'll talk to you soon. Thank you.
See you.